Do you want to learn how the learning in machine learning or an AI model works? And also, do you want to know why you should study at least a little bit of matrices and especially matrices multiplication to get even better in this world of data science and AI? Follow me for this class and don't forget to subscribe to the channel if you are new around here. This simulation that I have in the screen will try to accomplish a very simple classification task. A classification task in this case will be, look, I have some outcomes, in this case 0 and 1, and I would like to have a model that will simply help me to achieve these particular classes, 1 or 0, with a certain probability. In order to have that, we need a matrix, and the learning process, it's essentially matrix multiplication. It doesn't matter if we are speaking about a linear regression or if we are speaking about neural networks or the so sophisticated transformers that we have in the large language models. The first matrix and the main idea we have around it is that we will receive the value of the features of the attributes, the values that will describe the phenomenon that we are trying to explain with the model. So here we have two features, 1 and 2, with respective values on which each row is a new training example. Remember, in the machine learning, especially on the ones that we call supervised learning algorithms, they need examples to learn. The same way that you need to read a book to learn, we did an example of something to learn, the machines will follow exactly the same way. So each row being the training example and each column representing the feature itself, we will forward pass these elements through a matrix multiplication in order to have our final goal, that is the classification we want to have. In addition to that, you also have the weight matrix that are the parameters that will multiply the inputs of the matrix containing the value of the features, and then they will be updated to get to the result that you want. That it's 0 for y1 and 1 for y2. This updating of the weight values, it's exactly the learning that we have in AI and machine learning, right? It's beautiful. Down here, and I will leave the file for you to play around and to understand clearly the process. You will find it in om-qs.com in the blog session. It's for free. So here, as we will be training our model, the decision boundary, that is this dashed yellow line, will be shifting around in a way that we can, therefore, with a small or the smallest possible error, predict accurately what are the probabilities that we have for each one of the classes. So you see, as we do this training, that is this matrix multiplication, in each one of the steps, this dashed line will be changing as well. So let's go for the first round. So here we have the inputs, and then if you come here and run one gradient step, that it's exactly the first set of multiplications, and these multiplications are exactly these elements over here. So run the first step. Let me press the button for you. You will see that we went through the forward pass, that is multiplying the batch matrix by the weights. So it's X containing the features times W. So that will result in a Z matrix. That Z matrix then is for the logistic loss, that it's nothing more than a tracker that we would like to minimize. In order, by minimizing it, we are then able to get the result that we want until we update the weights measuring the error that we have now, the error that we had in the prior step, and then continuously we do this until we reach the optimization point. So pay attention to these numbers over here, probability 1 and probability 2. I will run another gradient step. So you see that after the step, we are getting down in probability 1 because our target is to get as close as possible to 0. And probability 2, it's increasing because we want to achieve as close as possible to 1. So each time I press the button, this is the learning. This is what, of course, automatically is done once you do the programming of a learning algorithm in this case. And then you see by this third run I gave, we already have the probability of 1 being below 0.5 and the probability 2 being 0.5 precisely. And the predicted classes, they are already 0 and 1. That is what we want to achieve. But why, Leandro? It's common sense that if we have equal or higher than 0.5 in a classification nation, we can already consider as 1 or eventually lower than that, 0. This can be changed. This is another subject. But here, let's say our model already achieved the goal. If we want to be even more precise, I can keep running the steps and you see this number is yet coming down, this number is going up until they reach a plateau. That plateau means that with this data in this algorithm, after a certain number of steps, we no longer have any improvement. So the learning process stops, sorry, and hopefully it would stop in a number that makes sense to us, that in our example, of course, it does because it's extremely simple. There are a few considerations to be done here. This learning rate, it's the amount of the steps that you give. There can be bigger steps or tiny steps. If the steps are very tiny, the learning process will take longer and eventually will never converge. That it's that idea of achieving the value or the loss that it's the minimum as possible. And if the learning rate is too high, eventually your learning process will be extremely fast. It will reach its end, but will not deliver you the outcome that you desire. So you always need to balance this element over here, right? So it's pretty cool. This is the motivation you should have in order to better understand matrix multiplication and understanding the role of matrices in AI and machine learning. And remember our friend over here. Let me reset the example. Let me just play around with the numbers over here. And the decision boundary that we have, look, each time we run it, it shifts. And in this case, it's horizontally set over there because we already reached our goal now. And then we see that we have the boundary, meaning that if we are at one direction or in another direction, eventually your outcome will be classified as 0 or as 1. So it's pretty cool. This is a really, I mean, simplified idea, but very accurate on how the learning process works and what are the roles of each one of the matrices and how they interact with other. Again, a classification process. If we go for the GPT models and other things, they will get bigger, they will get more complex, but yet, and this is my point, yet the principles, they are exactly the same. So go deep into that idea. You need to understand how this works you don't need to know everything about it, but you need to be very comfortable in understanding the dimensions, what are the rows and the columns, units must have in each one of the matrices in order you don't get any error in such calculations. But understanding this, it's truly understanding the learning. And once you understand the learning, you will see that machine learning it's a fantastic tool, but it's in the end matrices multiplication. Okay? So take care, trade safe. See you next time. Bye bye.